In this lecture, we are going to create our first class template. Before we do that though, let's recap a little bit and think about what a class template is. A class template is a class blueprint that can be used by the compiler to generate more specific class instances that we can use directly in our code. So a class template is not real C++ code that is processed by the compiler. It is a blueprint that you set up to make your job easier in making your class support multiple types. So for example, in the last chapter, we had a chance to design a box container class, and we have seen that it was really not flexible to make this class work with multiple types. Every time we needed to do that, we needed to create a copy of the class and copy the code and adapt that for the type. That was really ugly. That's not design you would want to do in your code. Class templates are a solution to that in that we can set up a single class template, which is really a box container template, and we can tell the compiler to generate an int instance for this template. We can generate a double instance, we can generate a dog instance, we can really generate all kinds of crazy instances for this, and this is going to work really well. This is the goal, and we are going to be exactly doing this in this lecture here. So we will make our box container class support class templates, and this is going to be really cool, as you are about to see. So because we will be using the box container class a lot, please go back to the last chapter if you don't know about it. We went through the trouble to design it from scratch, and every single design decision we have made is in there. So if you are ever confused about how it works, please go back and watch the chapter. You are going to have every single answer to your questions in there. And if you have any more questions remaining, I am always available. You can ask me and I will do the best I can to help you out. So let's do this. We are going to create a class template, and we will use our template declaration as always. So we have our template declaration here, and we will set up our class. After we set it up, every time we mention our class in our code, we are going to tell the compiler that this is a class template, and the compiler will know that it will need to do some job to specialize this class template for the type we want to create a template instance for. Now, one thing you should notice is that with newer compilers, and by newer compilers, I mean GCC 11, Clang 12, or MSVC 2019, if we keep doing things like we did before by putting in the T here, we're going to get weird compiler errors. I had to do a bit of research to figure this out myself. But with newer compilers, you don't have to put these T's in here. And the way to get this to work is just to ignore them. You see here, we don't have this angle brackets T. We don't have that right here. We don't have that right here. We don't even have that right here. I think you can leave these N, but just to play it safe, you can remove them, and that's going to make the compiler happy. So that's just a warning for you there. If you are using newer compilers, be careful about this, and the code is going to work. If you are ever confused about this, please go back to the GitHub repository. The code is going to reflect the current changes we have to get this working exactly like it should. So be careful here. The code is really going to stay the same, and the only thing we will need to do is to replace our value type we had in the last chapter with the template type that we have here. So for example, in our parameters, you see our parameter is T, which is our template type. We will have a T here in remove item. We will have a T in remove all items. And we will basically be doing this thing all over in our class. Okay, one thing you should know the moment you start working with class templates for your classes is that the definitions should show up in the header file. And the reason is the compiler is only going to look in the header file to look for what it is going to generate template instances for. If the definitions for your class methods show up in CPP files, they are going to be ignored by the compiler engine that generates template instances. And when you get to run your application, the linker won't be able to find them, and you will get undefined reference errors. So with templates, it is strongly advised to put everything in header files to give the compiler a chance to process the entire class template and generate necessary template instances. Okay, so all our member functions are going to move in the header file. And another design decision we're going to make now is to set up our stream insertion operator as a non-friend function. And it is also not going to go through our stream insertable interface because this would introduce problems we are not able to deal with now with class templates, but we will see how we can make this work later in the chapter. So don't worry, we just want to have something to start with to make our stream insertion operator work. So it is no longer going to be a friend, and if we need to access some private parts of our box container class, we will go through a bunch of public getter methods. This is what we are going to do here. Okay, let's look at some implementations for our methods. Here we have our constructors. Again, we have to make it super clear that they are implementations for methods of a class template, and we say that using a template declaration here. If this doesn't show up, your code is not going to compile. Please keep this in mind. Again, here we say that this is a template, and we say our constructor here. And notice that in the body, we change our value type to be our template type. This is what we do here to really give the compiler a chance to specialize this with whatever type we want a template instance for. So when we get to generate our class template instance, for example, and the compiler looks at this method, it is going to change every instance of t to int, for example. If we want to create a box container for integers, this is what is going to happen. We do the same for our other constructor. This is a copy constructor. We say this is a template, and we use the same mechanism to tell the compiler that this is a class template. And every time we need to mention our type, we will go through the template type as we do here. The code is really the same as we have seen in the last chapter. So we don't really have much to do now because the class was completely designed in the last chapter. All we need to do in this chapter or in this lecture is to go in and replace every instance of value type with our template type and make sure that our method implementations are decorated with the template declaration here. This is all we need to do. And we are going to do this for all the methods. Here is our destructor. We have our template declaration and we have our template type here. We have our expand method. So we have the template declaration and we say that this is a class template here. And every time we need to mention the type this class is working on, we say that using the T type. Let's look at our add method. Template declaration here, we have our type, and if we need to mention it, we will mention it in our code, but we don't need to do that here because that will be indirectly done with our expand method. We have our method to remove stuff. Again, we have our template declaration, we have our type here, and if we need to mention the type, we will do that in the body, but it looks like in this method here, we don't need to do that at all. Our remove all method is going to look like this, and we will have our template declaration and our template types in here. Let's look at our operators. So the template declaration is here, and we have our template type all over the place. We need to do this. And we do the same for our operator plus. Our copy assignment operator is going to look like this. Again, we have in the same piece of data. If we need to mention the type, we need to do that through our template type here. And one thing I want you to know is that it is possible to omit the template type inside the class definition. So if you look here, we are inside our class definition and we can not mention the T here and everything is going to work just fine. But I still recommend to put this in to really make it explicit that this is a class template. Every time somebody looks at your code, that's going to make things a bit easier to follow. Okay, another thing I want you to remember is that a template instance is only created once. So if, for example, we create a template instance for int in our code, this is going to be reused every time we create a new box container of int. So this is not going to be duplicating code. That's why we won't have code duplication in our code because we will have only one template instance for a given type. So I want you to remember this. Another thing is that class template members are in line by default to avoid any ODR violations if the class is included multiple times in our program, because we know that a definition can't really show up multiple times in a single C++ program. If things are not in line, You would be violating ODR because you would be having all kinds of crazy instances for your type spread across your program, and that would be a mess. So the compiler is going to make sure that if you put a method inside your class template, that method is going to be in line by default, and what that will do is constrain that method implementation to the translation unit where it is showing up. I really want you to keep this in mind. Okay, now that you know this, it is time to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is your first class template. We will grab our template files and put them in place. And I will also put in our box container class, which is using class templates. Because it is a lot of code, I am going to open this up. We are going to go through this together, and that's going to save us a few seconds. If you need this code, you can grab this from the resource section of the lecture. You can download this and use this right away. This is going to save you a few seconds, I guess. So let's open this up in Visual Studio Code and look at our box container class. It is exactly the same thing we saw in the last chapter, but now we have refactored this or changed this to use class templates. And you see, we have all kinds of crazy class template declarations in place. Again, one thing I should point out is that now I am using a newer compiler with the course. If we go to run task here, you're going to see that we have Clang 12, we have GCC 11, and these compilers introduced changes that are going to break the code as we have it now. And for example, if we try to build with the current setup here, so let's try to build, for example, with GCC 11. GCC is our favorite compiler. You're going to see that this is going to throw a bunch of weird errors. It turns out that these compilers don't like that we are putting these T's in here. So all we have to do to get the code to work is remove these T's. I am going to remove the first one. I am going to remove the second one here, and I am going to remove the last one. Let's do this. In these constructors and destructors, this is where we do this. And I am going to remove this little guy here. And if we build again, let's pass this through GCC again, GCC 11. Let's wait and see. You're going to see that now the build is going to be good. So to get the code to work, please remove these T's that we have in here. And GCC 11 is going to be happy. I think this is also going to work with Clang. Let's use Clang here. And we're going to see how this goes. I am just showing you ways to avoid these errors because I recorded the course with older compilers, and I have to take in these new changes to make sure you are using the best tools available. You see, the build is good with Clang 12. Let's try the compiler from Microsoft because I am doing this on Windows. And we should also make it happy because we want to write portable code. Let's wait and see. You see, the build is good. So this is a warning for you. Please make sure you remove these T's to make sure the code works with newer compilers. And again, if you are ever confused about this, please go back to the GitHub repository. The code there is going to reflect the current status we have for the code to work. And you're going to be using the latest changes we have in the code bases here. So with this in place, we can move on. So this is going to be our sandbox container class we know and love. And it is going to have our trusty member variable. You see that the member variable, which is a pointer to a type, is going to be modeled in terms of our template type. We have our size and capacity, and we have the same methods we really had. The only thing that changed is that we don't have the same type alias we had before to take into account that it is possible for the class to model multiple types. And we will be able to use multiple types through class templates. And this will save the trouble we had to do to copy files manually and change the classes to be, for example, a box container of int, a box container of double, a box container of car, like we had a chance to do in the last chapter. This is going to improve things a bit. Mind your steps though, because those copies are going to be made by the compiler, and you won't have to worry about them in your C++ code, but they will still be there. So for example, if we create a box container of int, the compiler is going to create a box container int implementation, but we won't have to manage that. The compiler is going to manage that. And the only point of contact in our C++ program is going to be this class template. That's what we can achieve with class templates, and I really hope it makes sense. So here we have a bunch of methods, and we have our constructors. We have a constructor here, a copy constructor. We have a destructor. And notice that we are using all this template stuff in here to tell the compiler that this is a class template. You really need to put this in. Otherwise, your compiler is going to be confused. So let's go down and look at the other methods. For example, the add method is going to add a T, and the compiler is going to replace in this type at compile time when it sees the actual box container that we are trying to create. So if we create a box container of int, the compiler is going to replace this to be int. So we will have an add method for int. We will have a remove method for int, and this is going to work for all the methods that we have here. We also have in our operators, and they are exactly the same thing we saw. This is really all. The other thing I want you to notice is that all the method implementations are now showing up in our header file. If we go in our box container CPP file, it is going to be completely empty. And this is what you should strive for if you try to use class templates in your code, because the compiler is only going to look in header files to look for things it can generate template instances for. So for example, if our operator plus here was implemented in the CPP file, the compiler would only find the declaration, which we would keep in our header file, but it wouldn't find the implementation that would be in the CPP file. And if we search for operator plus, I think that we are going to find our definition. So let's go down. You see we have our operator plus here. The full definition is in our header file. So this is our header file at line 185. Why is it saying box container CPP 185? Let's go there and find our operator. It is right here. And every single member implementation is showing up in our header file now. I don't think we need to go through all these methods because we did in the slides. That would be boring and wasting your time. What is going to be interesting is to go in the main CPP file and actually use this class template and see it create types that are really cool to work with. We are going to create a box container of int, of double, of all kinds of crazy types. We will even create a point class and create a box container of point, and we will see how this works. So let's include box container. We need that for this to work here. And we will set up our point class, which we are going to use to test and see if our box container type actually works with custom types that we created ourselves. And this is going to be really cool. This is going to be a good learning experience. We can now hop over in our main function and create all kinds of crazy box containers. We have a box container of int at line 32. We have a box container of double at line 40. We have a box container of point. You see, this is our custom type, and we are creating a box container for that. At line 48 here, we have one for std string, we have one for car, and we will see how all these guys work out. We can build this program and see if it is actually working. So let's pass this through our GCC compiler. We can close the sidebar because we don't need this anymore. The build is going to be good here, so we can bring up our terminal window or PowerShell window and run the program. You're going to see that it is going to do what we expect. Let's go back to our main function, and the first thing we are going to print is our box container of int. That's what we say here, and we are going to print that right here. It is going to have 33 and 44 in. The size is going to be 2 and the capacity is going to be 5. This is really cool. We have our box container for double, and we will put in 2 numbers and we will see them right here. So this is working. We'll create a box container for point, and if we go up, we're going to see our class implementation for point, and we have a stream insertion operator here, which is going to print our point. And if we print the points that we are putting in, we are going to see one is 20.1, 20.2, 200.22, and 200 and 300.33, and we see those guys printed out here. If we print our point, this is really cool. We can create one for a string. So if we put in hello world, we're going to see that printed out here. We can create a box container for car. And if we print that out, we're going to see that it is going to print our message here. This is really working. Another thing I wouldn't feel great about if I didn't show you is that we can actually test these things out with CPP Insights, a tool we have seen that could help in looking at the template instances that your compiler generates from your class templates. So I am going to copy the entire code we have here, and we are going to hop over to CPP Insights, and I am going to take out whatever I had in there, and I am going to put all the code I have in the main CPP file. And let's remove every other thing and show you that we can try this out for int, because seeing all these template instantiations would be ugly. So we will only leave in the template instance for int that we create here, and you see that we are using the add method, and we will print out this thing using our stream output operator. But if we go here, you see that we are including box container, and the code for our class template is not in. One way I like to do this is to put the code exactly as is. So I am going to copy everything I have in my box container header, and I am going to grab all the code for my class template, including the implementations and definitions for the methods. Let's go all the way to the end, and the last method is going to be our copy assignment operator. We are going to grab everything, and we can copy this and put that in our code in CPP Insights here. And once we do this and we go in main, make sure that we have our class created for int. Let's try and run this through CPP Insights and see the template instances that are generated for our class template here. Let's wait for this to give us a response, and looks like everything worked fine. We have our class template here, but if we go down, we are going to see that we have a class template instance generated for int, and you see that this was instantiated from inside CPP at line 248, and that happens to be the point where we created our template instance, and that happens to be right here. Okay, so let's look and see what we have in this template instance. We have a constructor, we have a destructor. You see that the compiler has marked this as no except because destructors are no except by default. We have seen this in a previous chapter. We have our size method, we have our capacity method, we have our get item method, we have our add method, and you see that we have all kinds of crazy things in here. And if you go down, you're going to see that the compiler has actually replaced in the template type and used our actual type. For example, here you see that if we are creating an array, we are going to create an array event because we created an instance for int on our class template here. I want you to keep an eye out for this. You can look at all the methods, but this is really not going to do anything fancy. It is just going to be a template instance for our type. If we go in, for example, and leave in the code for our point instance, let's go to the main CPP and grab that. I think we can do that. So let's grab the code for our box container for point. We can hop over to CPP Insights again and create an instance for point now. We can do that. And if we run this again, we will create an instance for point. Let's wait for this to go through. Okay, looks like everything worked now. We have our class template. But if we go down, we're going to find our instance. And let's go down and find this. We have our template instance, which was instantiated at line 249. And if we go down here, we're going to find that 249. Yes, that's where we created this little guy. We have this line here. And you see that the class now has been specialized for point. If we go down, we're going to find that this guy is now modeling a box container of points because our array is now going to be storing points. This is a dynamic array for points, and this is really what I want you to see. You can use CPP Insights to really see which template instances were created for your class. Okay, so now that we have seen this, let's keep playing with this in our Visual Studio Code editor. Another thing one would want to do is to try out most of the methods we have in our class template and make sure that they are working. And we are going to try and do that here. So we are going to try our methods out. We will create an instance for int. This is going to be enough to play with this, guys. We will add data and see this printed out. We will add more data and see this printed out. We will remove a 55 and see our data we have in. We will remove all instances of 10 and see our content as we see here. We will copy construct a box container and see what we get. This is going to work just fine if we print them out. And we will copy assign here. So we will take box 1 and assign that to box 2. And we will see how this works out. We can try our compound addition operator and add something to our box 2. We are going to see what shows up in here. You can really follow all these things and make sure that your box container is working as you want. Down here we see our operator plus, so we will add things up and have our copy stored in int box4, and we can print this out and we can see all these things working here. So let's make sure we follow this up in our terminal. I am going to build the program using GCC, my favorite compiler. You can use any compiler you want that supports C++20, and we are going to clear and run Rooster, and we will see what happens here. Let's go up and see the part where we try out all the methods. We will create a box container of int and put in 10, 21, and 44. If we print, we're going to see that here. If we go down, we are going to add 10, 55, and 10, and we are going to see that we are going to add these guys here. We will remove 55, and that's going to give us what we have here. And we can remove all instances of 10, and that's going to give us 21 and 44. That's what we have here. You see that the order doesn't really matter. All we care about is that the data actually shows up in our box container. That's why you see that every time we remove something, the order is going to change a bit. Because remember, the way we do our removal is to target the current index we want to do the remover on, and we're going to override that with the last item and then reduce the size of the box container. Again, if this is not making sense, please go back to the last chapter where we designed our box container class. You are going to understand all these design decisions here. We can also copy construct a box container object. So that's what we are doing here, creating int box2 from int box. And if we print these guys out, we're going to see that they have the same data in. We can achieve this. If we go down, we are going to see that it is possible to copy assign. So we will assign int box1 into int box2. And now the data we have in int box2 should be the same as int box1. If we print this out, we are going to see that we have the same data in. This is really cool. We can use our compound addition operator, and we are going to add int box to int box2. If we print int box and int box2, we will see that int box has been added to int box2. Let's look at that here. So int box had 33 and 34, and that was added to what we had in int box2, and that's reflected right here. We can also try out our operator plus, and it is going to do exactly what we expect here. This is really all I had to share in this lecture, showing you how you would go about and make your box container use class templates to make it really easy for your class to support multiple types. You see that now we have the flexibility of creating all kinds of crazy box containers for all kinds of crazy types without going through the trouble to copy the code here and changing things to support all types. The compiler is now going to take over that job and look at the actual box containers we are trying to create in our code and create appropriate template instances to make this work. We don't have to maintain all these copies. The compiler is going to maintain them. This is going to make our job a whole lot easier. We are going to stop here in this lecture. In the next one, we will try and zoom in on instances of class templates and see a few things you need to be careful about. Go ahead and finish up here and meet me there.